Hello again, and welcome back to Mapping Hour. This is episode 19. Very exciting time because, wow, you're getting to see all kinds of things that you can try if you've got a login with Publishing Powers. What did we do in 18? That was a project by Charlie and a project by Kylie, a deep dive that you got to track with us. And so, what have we got in 19? A deep dive into a project by Joseph, followed by one by Tom. So without further ado, let's just open it up for Joseph.
You betcha. Thanks. Folks, I would love to explore weather with you in this segment. I'm going to talk about how the project evolved, how it continues to evolve, some things that you can do in the lesson, and it's going to touch a little bit about technology, a little bit about content and data, a little bit about educational approaches. So look forward to hearing your feedback. Now, weather, I think many of us are weather geeks. Weather has a lot of connections to geospatial, but let me just start with this slide. I'm in Colorado from our previous Mapping Hour events, and this scene right here is a annual event that I've looked forward to for many years in Colorado. It is the advent of our bank cloud, our lenticularis and rotor clouds and other things that form on the lee side of the mountains. So we have weather coming in from the west most of the time in Colorado. And when it comes over the mountains, only in the fall, winter, and early spring do we get this bank cloud effect. And it makes for some really nice sunsets, as you can see here. But that touches on how this project actually evolved. Way back in the days when I received a printed newspaper, my family and I would, on Sunday mornings, look at the weather page, and perhaps you can relate to this experience. We would look at the high and the low extreme temperatures, and I began to see in my mind, as the seasons progress, you get a different pattern of where those highs and lows appear. So we would keep a physical manual table. That evolved into, okay, now I'm into GIS and education, and I can create a lesson based on data that I've compiled and put into a spreadsheet and then mapped. More about that in a minute. But focusing on weather is, I think, good in a variety of ways. First of all, it's readily available globally, as we'll see, not just your own local community. There's a lot of change aspects, and many of us love to teach with GIS because it touches on change over space and time, over scales, and so on. And unlike some other things like water quality and a couple of other phenomena that you can observe, weather, at least certain aspects, you don't need any sort of special equipment. You can observe percent of sky covered by clouds, for example, without any equipment except for these eyes of yours. And also thinking about what students really like to dig into, especially extremes and hazards, disasters. Weather touches on that too. So you can talk about weather-related events, floods, even wildfires, hurricanes, tornadoes, etc. So I began with this static data set that I compiled from this reading of these newspapers. And I decided to focus on, I've got a decent data set from 2004. And like you educators and parents out there, you get a data set that works. There's no reason to change it in some ways. So I used that data set for several years until the advent of around the time that Charlie was talking about and what he shared of ArcGIS Online. And then I thought, Joseph, why are you using this static data set? There's nothing wrong with it. I still have it, and it's still usable, but let's take advantage of some of the things that we talked about in the Mapping Hour. Most notably, this whole concept of the Internet of Things, digital devices out there that are feeding data to this cloud-based environment that we have. And these Internet of Things devices, stream gauging stations, earthquake seismometers, weather stations, traffic monitors, etc., have a location. And therefore, since ArcGIS Online, for example, is a cloud-based platform, you can get data from those Internet of Things devices, including weather stations and ocean buoys that we'll talk about in a minute. So I moved the project to a real-time feed, and I also began using ArcGIS Online for that. There are other things that are in this lesson that we won't have time to go into, but I like the whole idea of using weather data because you can touch on a lot of different kinds of data, including satellite imagery that may be 15 minutes old is all. You can use other kinds of data as you see here as well inside such lessons. But I'd like to, before we get too much into the nuts and bolts, to touch on something that Kylie mentioned last episode that I think is really important here. And that is what I believe is really the most important skill to cultivate in using geospatial technology, and that is being curious. Being curious, right? Charlie's really curious about his surroundings when he goes walking, and Kylie when she's running. And Tom's curious about lots of things. I'm curious about lots of things, one of which is weather. And so starting with that, I think drives many things. It drives you to be tenacious about using the technology, right? Some of those things that Kylie mentioned, for example, I don't use, but now I'm really curious about, I want to try some of those things. It also keeps you focused on the main educational objectives. If it's some project, some topic, we all have to teach things that maybe isn't our main area of interest, right? And we do it, but it's much more interesting to know that in GIS, there's no shortage of topics that you can examine, right? Because we have a very dynamic planet, weather being a great example of that. Isn't it great that we're not on, Mercury or Ganymede or someplace where there's not that much weather going on? We've got a really dynamic planet here, the Earth. And so being curious, I think, is the most important skill. It's more important than knowing how to buffer and knowing how to geocode. All those things will stem, I think, from you being curious about the technology and about the methods and about the planet and about your neighborhood, making a better world. So here's a screenshot. You'll see lots of tools here. You'll see lots of buttons. When we see stuff like this, several of us, and probably some of you watching this episode, would think, gosh, that's what we had to work with. It looks really complicated. And I've actually reduced, this is from ArcGIS 8, I've actually reduced some of the tools that you had available to you. But nevertheless, the focus was, as you can see, on weather. I got a satellite image in there. I made an elevation grid out of data. I've got some of the data points on there. And so we would go through this static data set, as I mentioned. Nothing wrong with it, but we can do better, especially now with these web-based tools. Another thing that I'd like to touch on here is, I think you're getting a sense from these mapping episodes that these projects evolve. They do, because the technology changes, because our educational objectives change, because our students change, right? Because our dean or our principal or whoever we're reporting to says, well, you need to do this now. There's lots of reasons to change and evolve, but that's one of the reasons why it's great that we have GIS as a platform. It evolves, sure, but don't stress out about that, because every time it evolves, it gets easier to use and more powerful. Easier and more powerful. That's awesome. That is incredibly wonderful. So if you're the kind of educator that thinks, okay, I'm going to create this lesson and I'm going to, it's just going to kind of coast for the next 10 years, that's not really what geospatial technology is all about. It's all about helping you to keep evolving these lessons. More about that in a moment. Also, I believe, little geographic quiz for you. Where is this? Think about that. This is a geographically and historical significant spot. Think about the following. There is no one single pathway when teaching with GIS, right? That's a good thing. There's lots of different ways, as you're seeing in these mapping hour episodes. That's also the challenge, though. Where do I start? What do I go out in the field first with my students? Do I start with ArcGIS Online? Do I start with web mapping applications? They're all good. They're all valid. Again, it circles back to your educational goals and objectives. I will say this about the evolution of this particular lesson. This one, as well as my lessons in the past, were longer than the lessons I write now. for several reasons. A, the tools have evolved into this wizard-driven workflow, where, like you saw in our analysis episodes, okay, you want to summarize within. Okay, where are your polygons? That's step one. What points do you want to summarize? That's step two. Do you want to make some options and adjustments? That's step three. What's your output going to be? Step four. It's this nice flow of how the tools work. And in the past, you really had to spell out for the students, okay, you need to go click on this button over here because it wasn't this flow. So that's one reason why they're shorter. Another reason why they're shorter is, I think, similar to you fixing your faucet at home. You watch Bob's faucet videos, right? 4 times or whatever it is, so you can figure out how to do it. So if the students get to a certain spot and they don't know how to do something, they're not going to read your next 5 pages in your lesson. They're going to go out and find a YouTube video, or they're going to find the geocoding help file or document, and they're going to figure out how to do it based on those things because they're up to date, they've got lots of graphics, etc. So you don't need to include all that stuff in your lessons anymore. And I think another reason why your lessons, your guidelines, whatever you want to call them, should be shorter is that if you make these things really long, then you're going to be stuck with this curation issue, right? That every time the tools evolve, if you've got this fine-grained third button on the left kinds of stuff in your guidelines or lessons, you're going to have to go in and update that. I wouldn't go there. I wouldn't do that. There was a time when that was necessary, but I don't think that time, especially in the 2020s, we need to do more about lesson development in the future. But has anybody figured out where this is? Spirit Mound, southeast South Dakota. Yeah, Lewis and Clark climbed it when they were on their voyage west. And you can see Iowa and Nebraska from there. Beautiful place. All right, there's 3 components in this activity. We're going to examine some weather patterns, we're going to predict the weather, and we're going to interpolate weather surfaces. I believe Tom, as a preview of coming attractions, is going to do a little interpolation with you as well. So this might be a nice segue. Couple of GIS objectives. You can read these, but it incorporates environmental science, some geography, some mathematics. I also like it because it's not just what is it like right now, what are the sky conditions, what's precipitation, wind speed, temperature, but what's it going to be like in your community in 48 hours? What's it going to be like in New York City in 48 hours, et cetera? Because again, it uses real-time data and we can do that. There are bigger objectives. We always have bigger objectives than just teaching GIS skills, don't we, folks? It's all about different phenomena operating at different scales. Which direction do the winds go clockwise in the northern hemisphere versus the southern hemisphere around highs and lows, dew point, a little bit about latitude and seasons, proximity to coasts, what's the weather like in your own community versus another place that's at the same latitude halfway around the world. There's all kinds of things in here. I will say this, though. Every one of this particular lesson is an example. It's one of the reasons why I wanted to show it to you, is that there is space in there for you to make extensions. Remember that diagram that Charlie showed? It's sort of like a parallelogram, right, Charlie? It was this, okay, I've got a scripted lesson, but I can do some, extension on it, and maybe if a student gets really interested in weather, they have a self-directed project or maybe even an independent project. So this has enough space in it where there's some extensions definitely possible, but it has enough structure that you can just run it as is. And before I leave that topic, I usually insert questions such as, if you were really a weather, like a meteorologist, for example, what other variables would you include? So it gets the student thinking about, okay, yeah, this is confined and there's only a certain amount of variables in here just to keep it doable, but there are maybe other data that I would want to consider if I was really a meteorologist working in the field. Okay, so there's those kinds of questions. Okay. It also focuses on this whole geographic inquiry process where we're being curious, which is driving our asking questions about the weather. How do fronts form, et cetera, proximity to the coast, and how does that influence temperature? And then we're acquiring some geographic resources. Again, this is going to be focused on the real-time weather feeds. We're going to explore the data in ArcGIS Online. There's no extensions or anything like this. It is purely an ArcGIS Online-based lesson. You're going to analyze it. You're going to use some analytical tools, including the interpolation tool. You're going to use a little bit of arcade scripting that Kylie mentioned last time, just for a little bit more power, just a wee bit more power. Aye, Captain. And then we're going to act on that. Okay, do we need to issue weather warnings? Do we need to watch the stream gauges in our community based on some maybe severe weather coming in? And then it leads to maybe to additional questions. The first thing we do, and I'm going to show you it live in a moment, we're going to set some bookmarks. So it comes back to the basics. Set some bookmarks at different places around the world so we can navigate to them. We also look at hurricanes. This leads into a small discussion about the following, and that is most of the answer keys that I end up writing, and I don't write answer keys for every single piece of curriculum that I write. But when I do, I have a lot of them that are answers may vary. And I think that's good because it shows that, for many of the questions, right, this is all inquiry-driven, problem-based learning. We're not saying the objective is not the single right answer. Some questions, sure, but there are many questions that there is no single right answer. In this case, the reason why I bring it up now is because the students might pull up the hurricane layer. This is active hurricane layer. And there might not be any hurricanes. Right now, it's April when we're filming this. And hopefully, there aren't any hurricanes right now. But maybe in October, there would be. So it's that kind of thing. So that's the kind of question where, okay, there are none, and therefore, I have none to analyze. Okay, let's take a look at this. After this slide, we're going to take a look at this live. What I have the students do at the beginning is they symbolize. You've done that in the mapping hour. We've done that with you. We look at temperature, pressure, and wind speed and direction. We do a little bit of statistical analysis, not anything too major, and the grade range for this, I've used this in secondary schools. I've also used it in undergraduate universities and community colleges. So just an example of the statistics. Okay, we've got, as you can see here, we've got 4,780 points, weather stations. So again, it's not just that we've got the real-time data, but it's global, and it's a lot more than the couple hundred that I had in my 2004 weather data set. And kind of like what Charlie was referring to a while back in a mapping hour, hey, the average temperature, 50, what are the units? In this case, it's F, degrees F, 50 degrees. Hey, that's pretty nice. But what about the extremes? That's the average for all of these at this particular time that we're calculating it. And again, the answers will vary depending on when you run the lessons because it's based on real-time data. All right, so you're probably saying, Joseph, enough. Let me see the actual data. Okay, so here is ArcGIS Online. It is our weather interpolation and prediction activity. And just to give you a little sense of this, I've got the current temperature on here right now, actually. So, or 10, 15 minutes old. Again, look at the metadata. Is it real time? Not quite, but it's near real time data. And so I can see here, let's get a legend. Okay, so the lighter colors, colder, okay. Got some upper Great Lakes, a little chilly right now. It's morning when we're filming this, late morning. But you know what? This is global. So, wow. What's it like in the middle of the Sahara right now? Okay, different time of day, right? It's late afternoon there. It's been heating up all day. And right here, it's 108 F. Okay, so what could we do as an extension? We could add the biomes. Like you and I look at this and say, okay, that's Sahara. We have a visual. Maybe I'm 12 years old. I have no idea what it looks like right there on the ground. So maybe add the ecoregions, add the biomes, add the mean annual temperature, a couple other layers right with your add button on the upper left. So you can extend it right there. Let's go back to content. I also have, as I indicated, the pressure. So some of the questions actually focus on the relationship between temperature and pressure. Right here, let's take a look. We've got at the moment, we've got low pressure. How do I know that? I've got a legend here. This is in millibars. We've got some interesting mixture of imperial units and metric units in this particular, but know your data, know the units. Okay, so what about the wind speed and direction? That would be interesting. And this in the lesson, they actually come up with how to symbolize these vectors according to the wind direction. It's really fascinating. Look at this. But look at this right there, just kind of southeast of where Tom is right now. There's this counterclockwise flow of air. So I'm going to, and this is part of the lesson, predict that if I've done a little bit of research, I know that air flows counterclockwise around a low, and there should be some low pressure there. And lo and behold, it is low pressure. And then if I look at the satellite imagery, I've got two things in here. I've got the GOES from NOAA satellite imagery. I'm going to go ahead and turn off gives me again, this is not real time. It's about 20 minutes old, so we're not quite syncing up with all of these data layers, but it's getting close. And so there's one more layer that I think is fascinating. Not all of those clouds are producing precipitation, so you can turn on the weather radar layer, and you can see, okay, there's some low pressure. It's flowing counterclockwise. There's some precipitation falling on both arms of that big low that is sort of wheeling toward the east. Okay, that gives you hopefully some sense of, wow, this is really fascinating data. And even if you're not a weather geek, right, you love looking at things over space and time. So let me give you a couple previews of what else is happening in the lesson, because I'm running a little short on time. So what the heart of the lesson is analyzing. But let me just say this. At this point where you have the students look at pressure, temperature, and wind speed, and maybe focus in on their community, what's it like right now? Oh, it's cloudy. Look at the map. I'm looking outside the window. That is fine. It is completely fine to cut the lesson off right there. That's what's wonderful about these activities that we've been showing you folks, is that at any moment you could just cut this off and say, okay, that's good. I'm teaching middle school, and that's all I want to do. That's all I have time to do, and that's all that we have the skills ready to do right now. Great. But if you want to dig deeper, you can keep going. And so in here, we look at extremes. So simple job of going to the table, sorting it, centering it on the hottest, the lowest pressure, the highest pressure, the coldest, and the windiest. Fascinating. So I love that part of the lesson. I can't lie. I love that part. And then, as the name implied, we predict. Now this is where one of two places where we actually do a little bit of, as Kylie was hinting at, arcade. It's a little scripting, I shouldn't say little. It's a powerful but simple, pretty easy to use scripting language, and you can use it in lots of different ways, as I'll explain two ways here. What we do in this section is I have the students subtract the dew point from the temperature, and if it's less than 4, remember in this case it's degrees F, that means the dew point and the temperature are pretty close, and that's a predictor of it's going to be saturated or close to being saturated. There's probably precipitation in those areas. So what they do is they then stylize the map, as you can see here, false or true, based on that expression, and they don't have to type it in. They can click dew point from a list of variables. Those are field names in your table, and then it appears in the expression. But it gets them a little bit thinking, okay, like a computer, a little bit thinking like a coder. So yeah, there's more things you can do, but this is a nice, simple way of getting students thinking along those lines, I think. So they come up with this map, blue versus red. Okay, if it's true, in this case, at this time I took the screenshot, those places are, according to this formula, probably saturated, so there's probably rain falling. Another thing that I do is I use a round function. I have them use a round function just so that, hey, I want to look at how about temperatures. And if I zoom in, this is all based on that, remember that visibility that we looked at a while back? I don't see the temperatures as labels unless I zoom in. So there's a label function, and one of the label options is I only want to show it at a certain scale. And notice that now it says 67 instead of 66 points. It's rounding. It's using the round function. So, if you're trying to get across this mathematical concept of rounding up to or down, this is a nice way to, okay, did it do what you thought it would do? Okay. And then, this is this is another one of my favorite parts, and that is you interpolate a surface. It's an analysis function in ArcGIS Online. We looked at those a couple episodes ago. The interpolate points. What it does is it builds a map that a lot of students are familiar with, a 60s degree band, a 70s degree band, an 80s band, a 50s band. So they're used to looking at those weather maps. Let's generate your own based on points. And also, I think this has been threaded in throughout our discussions. Just because you can doesn't mean you should, right? In this case, I actually have them use Charlie's state outlines layer. So they then select a state of their choice, could be a state that they're living in, but they interpolate a surface of temperature based on that state. So they cookie cut, they select the state, and then they interpolate the points, and they come up with this kind of thing, okay? So you see these bands, in this case, temperature. So let me show that for Idaho, for example. Zoom to. And remember, know your data. I did this last fall. So it's a static, at that time, shot of the temperature in Idaho at the time of that data, okay? So what if you did it for California and Nevada? Notice along the border there that it's not considering those weather points over like at Carson City, Nevada. If you included Nevada, the actual California interpolated surface would be slightly different, and I want them to see that in the lesson. Then I have them do it for Algeria. Notice that there's a lot of data points in Algeria. Those are temperatures near the Mediterranean Sea. There's not very many in the middle of the Sahara, in the southern part of the country. Now, the software will do it. It'll interpolate a surface, but the question in the lesson is, how confident are you in the interpolated surface when you only have a few points that it's basing on? So there's a little bit of, yeah, can I trust the data? Yep. All right, wrapping things up here. I do have a presentation. Remember presentations? Okay, here's my presentation. I start with this one. Ah, look at this. I bless the rains down in Africa. Yeah, Toto song. Meanwhile, in the Southeast USA, okay, there we saw that cloud cover. Slide 4, Idaho temperature interpolation. Slide 5, the California one. So I've got a presentation in there. And I also have a video on how and why the lesson came to be. So there's some extensions there. And just a last bit here. Oftentimes we think of, tools as hardware, software. Again, the tools changed, right? This tool was really precious to us, many of us, at one point. Now it's being used as a doorstop in a high school, in an actual high school in Colorado. So I took a photograph of it because I just thought it was so perfect for this illustration that, the tools change, but the objectives in this lesson are really, solid analysis, patterns, space and time analysis, and now it's actually sitting up there in the Learn Lesson Gallery. So if you do a search on weather, here it is right here, predict weather with real-time data, and you'll get the feeds, you'll get the lesson, and you'll be ready to roll, okay? All right, thanks, folks. Any questions from my colleagues?
That was awesome.
Thanks. I'm going to turn it over to Dr. Baker now. Tom?
Thanks, Joseph. That was great. I love that. I like weather too. That was, my family teases me about it. I tell them often that I was almost a meteorologist. That was my first college major. Can you believe that? It didn't last very long. As soon as I figured out you had to work nights, it was all over. Both Joseph today and Kylie yesterday have touched on some elements in work, GIS work and project work that we're going to revisit here as we explore my topic. I focused it a little bit differently, I think, than most of my colleagues did. And where Joseph, for example, was dealing with global data, I really wanted to get down to local data. And I was also very interested in what I might be able to do to help anybody at home collect this kind of data and map it, or anybody even at school, whether school is virtual or school's face-to-face. So I'm going to show you my project here. And my project rather is, it's under development. But this is a soundscape project, and this is actually a project right now that you can find an outline for in our GeoProjects hub page, which I think Charlie will probably have a reference to on the last slide. The question that I had that drove me into this place was, what kind of sound patterns are there in my own neighborhood? I live in kind of an interesting place in Kansas City where from the map, and this is actually my residential area, I live in this little location here with residents all behind me and off to the south and north, but off here to the west, there's a lot of commercial space. And so there's a lot of interesting sounds that get generated. So much as Joseph showed us near the end his interpolated map, I'm going to start with the interpolated map and try to work backwards here. I'll darken up the color here. We're going to just reduce the transparency so that you can see those groups of colors, so you can see the lines that separate them, those contours that help identify different groups of sounds. Now, what you're looking at is actually in decibels. So getting over to Joseph's points about knowing the units of data and knowing your data generally. So I want to back up out of that interpolation, generated the same way he described. We're just using an analysis tool in ArcGIS Online. But that interpolation layer was based on some data I collected with a Survey 123 form right on my cell phone. And so these dots here, these markers, are the actual data collected from my phone. So I can see on my decimal range, looks like my biggest points are just above 90. And I've got some points that are right around 70, 63 are my lowest. If you sit in a quiet room at home, you could expect to have 45, 55 decibels pretty easily, just from things like, say, a heater or an air conditioner or a fan. When you start to get into that 100 decibel range, it gets pretty loud. You're thinking probably at a concert, maybe you're at a train depot, or maybe even at like a race car track, that sort of thing, where there's a lot of very loud sound, the kind of sound that you'd really probably want to start wearing some ear protection around. So some of these places you'll see from my map are pretty dang loud. But as I look at the location where they've landed, they're at major street intersections. And a lot of that noise was, well, almost all of it was generated by traffic, and a fair bit of it from large vehicle traffic. So I did not use Arcade to stylize my pop-ups, but you can see that I have some of my data that was collected on display when I click it. And I have tailored the attributes that pop up. So I'm not showing everything that was collected, but just trying to get down to some of the more important attributes. Again, the question that was really driving me is, where is the sound the loudest in my area? And ultimately, if I mapped enough of it and I did it over time, I might even want to move along to that ACT stage where I recommend to different businesses that are local to me to consider setting up some devices or maybe vegetation that could help obstruct or absorb some of the sound that penetrates into the residential areas of my community. But before we get there, I want to show you how I collected the data. So this is effectively my final product you're looking at least final product to the moment, with my interpolated map, sound map across the top of it. You can see, based on the rather large decibel readings along these major thoroughfares, like 63rd Street on the north, and then Meyer along the south, but as well as this commercial district, that it really creates almost a box around, a dark colored box indicating where the areas are loudest. So you can see these lighter colors start to draw out where our homes, our residential areas are. So this interpolation, when it was ran, I restricted it to the range of where my dots currently appear. So I could, for example, if I started collecting more data on the next blocks north or south, I could begin to have a better idea of how that sound is passing around this community, how it extends out from this commercial area right here. So again, a work in progress, but this is something you can do at home. You could do with kids remote or face-to-face. So let's take a look at how we collected this data. And of course, as we spent some time on in previous episodes, I used Survey123. I really thought, I could use Collector, but then I thought I want to produce this application quickly, and I'm pretty sure that Survey123 had all the components, all the elements that you see here on the right that I would need to construct a survey. And for me, Survey123 is faster to produce this kind of instrument for. On top of that, I had some special requirements that I knew Survey123 was capable of. I'm also looking at multiple attributes. So it's a little too big of a project to try to get into quick capture. Quick capture would have potentially been interesting, but I'll show you in a moment here. I wanted to collect some data files that it really, Survey123 just shines at. So as we look down, this is a survey form I built. This survey form, as you can imagine, I had on my mobile device. I had on my phone. And I just wanted to collect some basic data to help begin to understand the soundscape of my community. So I provide an option here for my initials. And as we all discovered before, let's see if I can click on it to bring it up here. We'll see that that's a single line text box. Most importantly, I'm measuring sound. So I wanted to know the loudness in decibels. So I know roughly the decibel range is about -15 to roughly 100. And realistically, particularly for family or student data collection, you really don't want to go over 100. You don't want to encourage students in particular to try to find sounds, for example, that are over 100. So I even capped, I put a range, a min-max value on my integer input box here from -15 to 100, because I do not want to encourage particularly students to go out and collect those sounds that are particularly higher than that range. Device used. So you can tell from my development box over here that we are using a couple of different options here. Whoops, there we go. For device, and I just indicate here what they can select from. We do this because it turns out that the recording and the microphone, well, they tend to be different from device to device. So if we are looking for some degree of precision, and we're dealing with a large number of kids, maybe you're teaching an online class to 150 kids, they're all going to be carrying different types of phones. It might be useful to help filter out just on one particular type of phone. So I wanted to make sure I include that. And frankly, that's just good metadata to have. It's always good to know how your data is collected, what kind of probe it is, or what kind of device is used. And then, of course, this is a bit anecdotal. Describe the sounds. This is, what does the human ear hear when it's standing at this intersection? Is it mostly cars? Is it nature? Is it somebody hollering at you while you're asking why you're standing out, in the street with your phone in your hand? So that's another, I think, single line text. And now we enter into an interesting field, and one that we didn't talk much about, I don't think, before. It's the idea of attaching a file to our Survey123 form as we're collecting data. Now, I know before we've looked at attaching photographs, and in Joseph's presentation yesterday, he was talking about collecting sound, which was very interesting. Now, he was looking at a global perspective, and again, we're looking at a few blocks in our community, but turns out you can attach a sound file to a Survey123 app. Now, the preferred formats, at least at the moment, seem to be MIDI, MP3, or WAV. So one of the tricks, and we'll get into that in a minute, in terms of how we get that particular type of data, is you need to have a third-party app on your phone, much like recording the decibels, which I didn't mention, but you need to have the right third-party app on your phone to get that data. So we'll go through that in a minute. But here we can upload an actual sample of the sound file. Now that one's optional, as we've clearly indicated, because for some people that's going to be too much of a stretch. But it is really cool when you can pull up the sound data. Of course, time and location. Time and location, anytime you're out in the field, I can't think of a time when you don't need to collect time and location, time, date, and location. These variables help provide a context for any environmental data, right? Thinking about sound alone. Well, the sound varies whether I record it in early morning, say at 5 a.m. when I'm the only one up and maybe the birds, or at 5 p.m. when at my house near a commercial area, I can also hear a lot of traffic. So the time of day is very, very important. Even if we think about it, the day of week is important, right? The traffic patterns in my area, for example, would be very, very different on a Wednesday versus, say, a Saturday. On a Wednesday, at least in the normal Wednesdays, everybody'd be driving back and forth to work at certain times of the day. On Saturday, it's probably going to be a general roar from about 11 a.m. to probably about 6 p.m., right? So there's reasons to capture this. Now, maybe we won't be collecting enough data in our little survey if we're just looking at backyard sounds or neighborhood sounds. But if your project grows, this is really important. And of course, we've already begun to see why the location is important. In our case, we want to know location because we want to know how close it is to the commercial space, how close it is to major thoroughfares versus, whether or not it's in your backyard. So this is a form that I designed to collect sound data that was used to help produce this map and that interpolation. So at this point, I'm going to try to share with you my smartphone, and I'm going to show you the data. We are going to try to show you a screen from my phone and show you, there it goes. Okay, so I happen to be using an iPhone, and I am using and actually it's an older iPhone. This is, I think it's a 6. It's one of the larger style phones, but it's an older generation. So I'm going to pull up the form. It's the same form we just saw in the browser on my computer. And you can tell that here's my data. It's my initials, my decibel reading, my device, my file attachments. This is all great. This is all what I expected. So if I fill out the form, and I'm of course sitting inside at the office right now, I'll put my initials in because if multiple people are collecting data, it's always nice to know who reported some really interesting or maybe weird data that we need to go back and maybe ask a few more questions about. Now, sitting here in this room, I'm going to flip over to a third-party app that I have on my phone. Now, it should be, and it is, it's changing as I sit here, largely because I'm talking into it. One valuable thing about this is that this particular app will show a 1-minute average. So sitting here in the house, as I'm talking into it, my average is dropping, which is probably because I'm also running the Zoom client at the same time, and it may be blocking off my mic. So on your phone, when you go to an app store, what you would be looking for is any type of metering application that has the capacity to show you the current decibel reading of sound. So that particular application I use doesn't also record sound. So I also, while I was there, downloaded an audio recording app. Now you may already have one of these on your phone, but in my case, I wanted an app in particular that when I hit record, I could stop and start it for maybe a 10-second run, and then it would save files off onto my phone. So you can see from my screen here that I have an app right here. I have a recording right here called Ice Cream Wave. Remember, the WAV file is a format that our form is capable of receiving, and the ice cream is a note to me that I recorded this sound file near the ice cream store on my last walk. If I don't submit the data right then and there, say I have a logbook with me, maybe it's too bright outside, for example, to see your iPhone, or you're moving too quickly, this allows me to go back and rebuild the data when I get back into a place where I can submit it. So because this is a WAV file in this particular app, then what I have to do is actually share it. And when I share it, I can share it to files on my phone. And as I do that, it will say, okay, we're going to drop them in a known place. In this case, it's just inside my just inside my folder. So when I go, and let's see, we're going to kind of create some fake data for a moment. We're going to go, that was at 60, and we're going to say we are submitting here with an iPhone, and other details, of course, maybe we'll say, well, we're going to say this is indoors. And then we're going to say, yep, I've got a file. And look, on my iPhone, I've got all kinds of WAV files because I recorded all my data on this. But I scroll down and I'm looking for my file of choice here. And you'll see that we've got all kinds of options, but there's my ice cream data, and it's going to load that sound file right up into my browser. And then, of course, to help locate my position for where the data was collected, I can either pan and zoom, or I can punch in my street address. And with all that, I can then submit the data back into Survey123, and we can begin to analyze it. So we're going to try to stop screen share. It looks like that's working. It's great when all these tools work together. And I'm going to one last time show you what my desktop looks like as we take a look at the data inside of Survey123. So now we can see my data points that have been collected. We can see my attribute tables. And of course, we can also do a quick analysis of some of the data that's come in. So our first column here is locate loudness in decibels. So we've got a nice range here. We can get a quick understanding of what's going on without looking at it even in a map. That one's not going to be too helpful for us. This is really the most important, probably, because this is our integer data that we collected out in the field with our app. Last thing I think we'll show you here is just a reminder that because we collected those sound files, we're going to take a look at a single point just to verify that that WAV file actually attached. And there's a WAV file attached to that point. And we were looking at the ice cream WAV file earlier. I happen to know that's where the ice cream shop is. Don't ask me how. But there it is. There's my ice cream WAV attached to the point. Now it pops open in a new browser. And there's not a lot of audible sound here. You can hear some traffic coming over Zoom. It's probably not good at all to listen to. But all of our data is right there. We've got our attached files. We've got our decibel data. And then, of course, most interestingly to me anyway, is this really cool interpolation that we have to help us better understand the geography of sound in our community. Are there any questions from my colleagues?
Ooh,
Charlie, yeah,
I've got one. In your interpolation, can you show your map again? And I'm interested in the number of dots and the granularity of the interpolation. So how many dots, if somebody wants to get a good interpolation and get a good set of data on there, how many dots would make sense for them to get?
Well, hey.
I mean, could they do it with 2?
Can't do it with 2. The general rule with interpolation is the more dots, the better. Now, our tool in particular here is looking for at least 10 sampling points, and it looks like I've got about 13, at least in the data set.
Okay.
But you'll get better granularity the more points you have. And one of the advantages, one of the interesting things about interpolations is that it's making a prediction between your points. It's looking at the space between point A and B and C and D, and it's saying, well, there's no actual data here, but if we interpolate it, we're going to use a mathematical formula and guess that maybe that's about what your decibel value should be at that location. So that educated guess gets improved typically with every sampling event you have. Make sense?
Okay, it does.
And one other thing I was going to tell you is that if you go out with your iPhone like I did, and you're recording sound and you're recording decibels, and maybe even you're taking pictures when you're out collecting that data, take one of these along, right? These little portable batteries. This one's a big portable battery. May not be that portable, but these are portable enough, and bring along a charge cable, because you'll run your battery down, and you don't want to be halfway through a walk or a hike on your investigation and just run out of battery for your phone. On top of that, it's not all that safe. So be sure to take a battery with you. Any other questions?
So I have another question. Would it?
You only get one.
Well, I'm faster than Kylie here. Would it matter if the students who are taking this are working with different phones and different software pieces for collecting the decibel readings?
It probably would, actually. If all of your students are on iPhone devices, there's probably enough similarity that you wouldn't have a problem. If you have the luxury of teaching face-to-face and you're doing this activity, have all your students stand in one room. Have everybody be quiet, turn on your decibel meter, and see how close the phones match up. That's a fairly easy way to do a little, ground truthing. You might also try doing it in a noisy space, kind of get the high and the low range to see how closely they're aligning. But that's part of the reason why that question is on the survey about what kind of device you're using. And you're right, if a teacher can recommend that all students use the same recording device, both software and hardware, that's great. They're probably not going to have that option with hardware, but certainly with the apps they choose, try to get everybody to stick to one or two apps. The app shouldn't produce as much difference, but they could. So test them out. Make sure they at least all kind of work together.
So sort of calibrate them, and then if there are some consistent differences between brand A and brand B of hardware or software, can you then just say, okay, we're gonna change these guys' readings so that they're matching down here? Okay.
Yeah. Just in in ArcGIS Online, just create a new field in your data set, and you could create a calibrated column, right? And that's what you could run your analysis on, particularly if the data coming out are quite different from say phone model to phone model. Yeah, but doable.
Okay.
That's what I got for you today. Unless Kylie's got a question.
Outstanding. That's really cool. All right. What did we get to do? A project by Joseph and a project by Tom. And some really cool capacities there. We've touched on each of them in the past, but the power of these tools, real-time data, and working with the analysis tools, this is real GIS that they're doing. When they can engage these kinds of data sets, current data sets, their own data sets, and do full-scale analysis with them. Back in the days when it was before analytical processes got added into ArcGIS Online, people were saying, yeah, this is web-based mapping, but it's not real GIS. I didn't loudly disagree with them, but in my heart, I disagreed with them. Now, with real geoprocessing that you can get into with these web-based tools, this is really true GIS. And the power of these processes in student projects or teacher projects gets people engaged in the activity, get them gathering their data, get them analyzing their data, and then turning it into a presentation about it. And it just makes all the difference in the world, because that's what people in the GIS professions need to do in all of their work. So that's it. Once again, you could go back to these resources for story maps in particular, or the resources from the previous episodes, Tom did mention about the geo projects. There they are. That's where the Soundscape project is. Go take a look at these and join us for episode 20, the last of the Mapping Hour episodes. We'll see you then. Thanks a lot. Bye-bye.